is that you wouldn't have used all the variables already. So ax, and we also don't have to deal with subscripts. So ax plus by plus cz equals d. Create slider. All right, vector ABC. All right, this is the same vector that is related to these coefficients in your plane. All right, we'll discuss what that all means next class. So hit enter. So we have a vector. Then start with f, right? Because GeoGebra has designated your plane equation as E. So it needs something for you to reference when you want to operate with this equation. So it's called it E. So E is taken. So we got to use something else. So f x plus g y plus h z equals j. Skip I because GeoGebra designates I as the imaginary unit I. So it thinks this is square root of -1. So it's going to give you an error message if you try to do that. Create slider, create your vector. Something called a normal vector, FGH. All right. Then we're going to find the intersection. If you just type in intersect, it'll bring back the intersect path function, but I put these instructions on there, so why not? My first plane was E, my second one is I. Hit enter. And it blanks out completely for some reason. Well, I suppose there should be some kind of intersection. There we go. With the coefficients that were there, there was no intersection, so it didn't give me anything. But now it gives me something, and it is they're using lambda as a variable here, but it is basically a parametric form of an equation. So you can see it's right there. Now it's just a question of what all those coefficients mean, right? But you can see clearly that there is an intersection, and that line represents the intersection between those two planes. All right, so what do you do from here? Oh, and just be careful, because if you change things up, it may not be E and I, so don't fall in love with E and I. It might be something different. All right, so you answer each of the questions. The normal vectors are those vectors that we created. So we created the equation of a plane, and then we created a vector. That's the normal vector to the plane. Right? What is the relationship between two planes when their normal vectors point in the same direction? Relationship between two planes when their normal vectors are orthogonal to one another. In order for two planes to intersect, what must be the relationship between the normal vectors? All right, so elaborate on these things. Keep it away from being just one-word answers. And then use the sliders to find the intersection between these. And what I need from you on this is to give me your answer in the lambda form that that GeoGebra is giving us. All right, so just put in what it has there. Two ways to handle that would be you could, if you want, just screenshot this. Right. Once you've manipulated this, you can just manipulate your sliders. You don't have to drag them. You could just click on the coefficients and overwrite, and it'll change it. So if I made that a 2, for example, it'll make it a 2. All right. So you can type this in there. If you go into Google Docs, there is an option for math operations, and one of them is Greek letters. So you can grab the lambda from there, or you could just do a snip of this and just paste it in. So I leave that up to you. And also, I want the screenshot of your intersecting planes on the proper settings, because when you share it with me, it doesn't always come in the settings that you have it at when you hit share. So I want something that I can manipulate, so your GeoGebra links in your Google Doc, but I also want a quick screenshot of these two particular planes using the sliders. So you've manipulated the sliders to get these two planes. You have the solution and a screenshot of those two planes. All right, so nothing too crazy. And then copy the links to your work, so the same general statement there. All right.